Hello everyone, I'm Sami Sadawi. I'm a technical manager at La Chance Group. Today we will talk about bile acid in animal nutrition. Bile acid is produced by La Chance Group since more than 10 years ago. Bile acid is a pioneer product produced after a long time of research and investment by our group. If we talk about bile acid is molecule produced by liver, sensed by the liver and stored in gallbladder. First, to start with bile acid, we need to define and to make identification of bile acid. Bile acid mainly sensed in the liver from cholesterol. Cholesterol then converted to 7-alpha hydroxylase and then produced cholic acid and chenodeoxylic acid. Both of them, chenodeoxylic acid and the cholic acid, is combined with taurine and glycine to make bile salt and then to store it in the bile. After eating the food, bile acid is secreted from the bile to small intestine, combined with pancreatic lipase to break out and digest the feed. From this point, we will focus about bile acid sciences, and for the next part, we will talk and discuss about the mechanism of bile acid and how bile acid can assist in fat digestion and also assist in regulating the other nutrient metabolism for carbohydrate and protein, in addition to other function. So from this part, after bile acid secreted from the liver and stored in bile acid, when we eat the food, it is started to secrete it in the small intestine, mainly in the duodenum, and to be absorbed in the third part of intestine. It is named ileum. It absorbed via small intestine wall by apical bile acid co-transporter. After that, mostly 95% is returned back to the liver via peripheral circulation or hepatic circulation. About 5% is goes through to the large intestine, where in the large intestine to combined by the action of bacteria located in large intestine to convert it to bile acid salt. How bile acid salt can be made? It's made by this bacteria to convert the primary bile acid. Primary bile acid is cholic acid and chenodeoxylic acid, and the secondary bile acid like lysocholic acid and also deoxycholic acid. Some part of them is returned back again to the liver for resecreted and to reused again in the cycle. And a small part goes through to the large intestine and then secreted in the feces. This is a brief about the bile acid synthesis and secretion. If we go to the next part about bile acid and the fat and how bile acid can make action in fat digestion, so let us start about the fat. So what is the meaning of the fat? So everybody eat fat every day. So what's the meaning of fat? Fat, it is a triglyceride, and the triglyceride is a Latin word combined the two words together, tri and glyceride. Tri, it is meaning of 3 fat acid at least, and the glyceride, it is a glycerol or glycerin, sometimes named glycerin. So 3 fat acid and the glycerin combined together by ester bond. So that is the meaning of triglyceride. Triglyceride, that is the meaning of the fat, and also there are many sorting and many categories of fat based in many factors. Sometimes they sorting and they distributing based in the saturation and unsaturation, and based in the essentiality and based in the chain of carbon atoms. So let us first about the saturated and the unsaturated. Unsaturated fatty acid is combined to double bond, and this is to be converted to saturated fatty acid to be suitable for the absorption and to go through the metabolism cycle. And to convert from unsaturated to saturated, this action did by microflora in the rumen. For the second part of fat, essential and non-essential, so the difference about the ability of our body to sense this kind of fat. As example of essential, the famous one like omega-3 and omega-6. So that is essential. Why non-essential? Because our body can't be able to sense this kind of fat. Then, to provide our body with the need of this kind of nutrients, it must be to added from the diet or to be added as a external supplementation. So that is the second kind of fat. And the third kind, based on the chain and the number of carbon atom. So in this case, it divided fat to three categories: short chain fatty acid, and this contain 3 up to 5 carbon atom, and the second one, medium chain fatty acid, and this is from 5 up to 12 or 14 sometimes. And the long chain fatty acid commonly start from 14 and more than 14 carbon atoms. As there are many kinds of this for short chain, as example acetic and propionic, and for long chain, as example palmitic acid and stearic and omega, and many kind of this. What is the role of fat and why we eat fat? We need fat because this is a high source of energy, and this is provide a lot of requirement of energy to support our body for many function. In animal side, when we add the fat, the main functionality of fat to increase the energy density of the diet. Why? Because the density of the diet, especially in animal diet, it contains a lot of fiber and it contains a lot of carbohydrate, and in this case it is low in energy density. In that time, the energy density in this diet, it may be not able to provide the whole nutrients, so we need to provide the need of energy. That is mean we need to add external and supplemental fat to increase the energy density up to meet the nutrient requirement of the animal, especially for high producing animal and animal in the peak. This is in addition, the fat may part of the diet. As example, in animal diet, it contains up to 6%, and for the high producing animal, it can increase up to 7% as a part of dry matter intake. In general, the basic diet has about 1 or 2 up to 3% of the fat as a dry matter percent of the diet. This amount of fat in the basic diet most of time is suitable to provide the needs of the animal, but in some cases, especially for high producing animal, it should to add extra fat to meet the needs, because the amount of fat in the basic diet not enough to meet this demand of animal. About the fat in animal diet, we have many different fat in animal diet. The first one, the fat located in the basic diet as a part of the forage like alfalfa and corn silage, and the fat located in the concentrate like corn grain, like soybean meal and the other oil seed stuff. The third part is the fat that we need to add external source as a fat supplementation, and in this part there are two parts on this part. The first one, the fat from oil seed product from plant originated, and the second part to make this external source as a protected or encapsulated. Why we make the encapsulation in fat of animal diet, especially for ruminant animal? Because this fat is hydrogenated, is hydrolysis inside the rumen by the action of microflora. So we need to support all this amount and to reach to the small intestine to provide the whole amount and the focused amount of the fat. So for these cases, the industry is going to make a encapsulation or protection to make a cover and declination of the fat to avoid the action of microflora when the fat goes through the rumen. So in that case, we can able to provide the animal with a concentrated amount of fat to reach to the small intestine, so to be absorbed and to make the functionality. So what is the difference now about ruminant and monogastric animal? There are some difference based in anatomical, digestion, and the content and the component of the stomach. The ruminant stomach is compartment or ruminant. So what's the mean ruminant? What's the meaning of ruminant? Ruminant, that is means the animal has a rumen, and this rumen is to store the feed and then to record or re-showing the feed, to recall the feed from the rumen to the mouth again, and they make a cut to make it to the small part, and in this time to make a stimulation of the saliva mixed with the feed, and then to re-back again to the rumen to complete the digestion process with the microflora, and then goes through to the enzymatic digestion from apomeism and complete to the absorption. For the monogastric and the non-ruminant, as example here we can take the poultry. As we mentioned now about the different and the differentiation between ruminant and the monogastric, there are some difference. For ruminant, it is 4 compartments, contain 4 room or 4 compartments. The first one, it is the rumen, and this is the large part, the rumen, and the second part reticulum, and the third part omeism, and the last one, the last part apomeism. If we talk briefly about the function of each one, the rumen, it is the food. It is stay for a long time in the rumen and contain the microflora. This is makes the action of digestion and degrade the food component. It can say the rumen, it is a large fermenter. So the microbial digestion is started in this part, and the second part reticulum. This is you can say this is a tube connected the rumen and omeism. The omeism, it is this part, it is drying the food or absorb it, the water from the digestion or from the feed. The last part, this is the apomeism, and this is one of the important part. Here in this part, the enzymatic digestion is occur in the rumen. That is mean secretion of some enzymatic is secreted here in this part, as example pepsin to assist in digestion of protein, and also secreting some acid like hydrochloric acid, and this is assist in making the pH of apomeism in acidic level about 3 up to 4. So this is a prime functionality of the rumen. In other side, in monogastric, as example of poultry, you don't have this 4 compartment, and the stomach is just simple and they contain the enzymatic part to digest and to take out the feed. And here in this slide we can show what is the main difference between together. For the next part, as we defined now the fat and bile acid and the synthesis of bile acid. So the next part, how bile acid can do this work and what is the job, that is mean what's the mode of action of fat, and how bile acid can assist in fat digestion in addition to contribute to additionality function in fat and protein and the carbohydrate, and then assist in signaling. The mechanism of fat and absorption in ruminant animal, it is started with the feed. The first one, we need the feed to reach to the small intestine as a free fatty acid, and then to be absorbed via small intestine wall or epithelium, and then to be carried out by lipoprotein to the lymphatic, then to be secreted in the milk or to be stored in the body. That is mean the fat to be absorbed, it should be converted to free fatty acid. And how can we make these steps? To make this step, we have 2 main steps that occur in the rumen. The first one, it is the hydrolysis. As we mentioned at the beginning of this presentation, triglyceride and the fat is contained, it is a combined of 2 molecules. Fatty acid combined and the glycerol. So we need to break down this molecule, the fatty acid, and the glycerol is connected with the ester bond. So to make it free, we need to break down this bond, to break down the ester bond. So how can we make this? Microflora in the rumen can digest it easily. So the first step, it is named the hydrolysis. The second step, to convert unsaturated fatty acid to saturated fatty acid, and also as we mentioned and took this distribution and the definition of the fat and the categories of fat. Unsaturated fatty acid, it should be converted to saturated fatty acid. That is meant to convert the double bond to single bond, and this job also is did by microflora. So microflora did this two job in the rumen. After that, fatty acid is going to the small intestine. Inside the small intestine, in the duodenum part, the secretion of bile acid combined with the enzymatic secretion from pancreas lipase. Combined together, bile acid started to make the emulsification, that is meant to increase the surface, to increase the surface of absorption. So when lipase started to make the action, so we have the large surface, that is meant to increase the capacity and the efficiency of lipase. So secretion started in the first part in the duodenum to make the micelle. After micelle is formed with the combined of bile acid and lipase, started to be absorbed. The absorption occurred in the second part of the small intestine in jejunum. So this is the second part. We have three parts in the small intestine. The first one duodenum, second one jejunum, and the last one is the ileum. So the secretion of bile and the lipase occur in the first part of the small intestine in duodenum, and the absorption start in the second in jejunum. Here in jejunum, the absorption from micelle and free fatty acid to occur in this part. Absorption of free fatty acid by the gut wall to occur in this part. After absorption and inside the small intestine, inside the gut wall of the small intestine, to reconvert it back free fatty acid to triglyceride. After that, it is need to move and to carry out the triglyceride to the lymphatic, and this action is did by lipoprotein and the chylomicron to carry out the triglyceride from the small intestine gut wall to the lymphatic system to be secreted in the milk or to be stored in the body tissue. In this part, I would like also to mention that there are some kind of fat secreted also in the milk, especially for, as example, for dairy cows, as example for short chain fatty acid like acetic and propionic and butyric. This kind of fatty acid is not moved from the small intestine, but instead it is absorbed from the rumen wall to the bloodstream, and is then to be secreted and manufactured in the udder of the animal, and is then to be secreted directly in the milk, not to flow this direction. This direction is mainly for the long chain fatty acid, started from 14 and more than 14 carbon atom. But for short chain fatty acid, this is synthesized inside the udder of the animal with the process named de novo fatty acid synthesis. So in this part, this is the mechanism and the mode of action of fat and bile acid, and what is the role of bile acid and the role of lipatic enzyme in digestion and in absorption of fat in ruminant animal. This is the main part, as bile acid work as emulsifier, but this is not the main role. There are also many roles that bile acid can involve it in animal nutrition. For this part, as a bile acid work as emulsifier, the second part is working also to participate in triglyceride metabolism. We took in this a brief, and also we are planning in future to prepare for additional series in ruminant nutrition and bile acid, and we will discuss in detail this issue. But for this part, I would like to mention how bile acid can assist in fatty liver disease and how we can solve it, because this is one of the main problems, especially for transition dairy cows and the fatty liver commonly combined with the ketosis. So these two diseases is combined together and they make a lot of disease and make a lot of money for the producer. Why I mention this here? Because this is one of the important problem for the dairy farms that face. So we need to try to assist the farming and we need to provide the solution. So bile acid, one of the unique and innovative products that can assist in decreasing the incidence level of this disease and improve the animal performance and the milk production, and finally increase the income of the animal. For this part in triglyceride, I would like to mention one point, and for the next webinar I will talk for the remaining part. Here, as we know, for the lipid metabolism in ruminant, adipose tissue started to hydrolyze lipid to make NEFA. NEFA, that is mean non-esterified fatty acid. Non-esterified fatty acid has two direction, is to be secreted directly to the udder and to go to the second part to go to directly to the liver. When the NEFA go to the liver, it has two direction, to be oxidized, that means oxidation, and the second part to go to esterification. If it is go to oxidation, that means to make energy to support the body and produce also carbon dioxide. But this is occur when the oxidation is complete. That is mean if the oxidation is complete, so the NEFA can produce energy and the carbon dioxide to support the animal. But what will happen if the oxidation is not complete? So this is a problem, because NEFA instead produce ketone body. Ketone body like beta hydroxybutyrate, acetoacetic, and acetone. So this is the famous component of ketones body. In the second part and the second direction, if the NEFA going to esterification. Esterification, that means to produce triglyceride, and also is the fact as we discussed at the beginning of this presentation. Triglyceride go to two directions. The first one to be stored directly as the liver, and this is one of the main problem, and we don't need to go through this direction because this is make fatty liver and they make problem. And second direction to be converted to FLDL, very low density lipoprotein, FLDL. After that to be secreted in the udder of the animal and secreted in the milk. So in this direction, to decrease the fatty liver, so we need to stimulate conversion triglyceride to FLDE. And how can we make this? There are many strategies to stimulate the conversion of this. One of this to using bile acid. Bile acid can stimulate hepatocyte cells in the liver to convert the triglyceride and synthesize very low density lipoprotein, and this is what we need. So I emphasize about this point. So we have now a solution in our hand to assist a producer to decrease fatty liver in this regard. For the next part, for the ketosis, our company did many trial and experiment in dairy cows and in transition dairy cows. For the next webinar, I will share with you the result and the detail of this experiment and the conclusion and the recommendation from our product. So for this part, I emphasize the two main problems that dairy farming faced for fatty liver and ketosis, and we try to provide the solution of them. Here in this presentation, I focus about fatty liver, and for the next webinar, I will discuss in details about the ketosis and the trial conducted here in our company in China in leading dairy farming to evaluate the effect of bile acid in ketosis and what's the benefit that we can gain after using bile acid. This is some of the function of bile acid in addition to lipid metabolism and the carbohydrate and protein metabolism. Bile acid also can activate FXR, farneside X receptor in the small intestine. FXR, it is a receptor of bile acid, and after activation of bile acid, it activates the transcription of many genes that involved in lipid metabolism and carbohydrate metabolism. In addition, also FXR can regulate the biosynthesis of bile acids. This is the main function of bile acid. So in addition to working as an emulsifier, so he did additional work in participating, involved in metabolism and doing signal molecules. So this is in this presentation. In the next webinar, as I mentioned, I will prepare for the additional webinar how bile acid can assist in decreasing the incidence of ketosis, and for the fatty liver also in some experiment, in addition to some trial in young calf and in beef cows. That is all in our side today, and I would like also to invite you to attending for our planning webinar, bile acid in dairy cows and solution for minimize metabolic disorder disease. Again, thank you all for your attention and for your cooperation.